Welcome to this explainer on the Xstore Office broadcaster system. If you've ever dealt with retail systems, you already know that capturing data at the register is really only half the battle. The real magic happens when that data is shared with the rest of your enterprise. Today, we're going to unpack exactly how retail data travels smoothly and securely across complex technical systems. Let's take a quick look at our agenda for today. We'll meet the broadcaster system, look at the 3 PosLog data formats, peek inside the database table, cover processing and error handling, talk about maintaining system health, and finally look at customizing for your unique needs. Section 1. Meet the broadcaster system, the universal translator of retail data. So, have you ever actually wondered how your point of service data makes it flawlessly into wildly different external systems without completely breaking a sweat? The registers create the data, it gets replicated up to Xstore Office, sure, but how does it get handed off to third-party systems in exactly the format they expect? Well, the secret sauce here is its incredible flexibility. The broadcaster's architecture is totally technology agnostic, meaning we aren't locked into just one way of communicating. It can dispatch data to standard FTP servers, integrate with REST or SOAP web services, dispatch to message queues, fire off emails. Honestly, it could even broadcast your data to a Twitter account if you really wanted it to. It just doesn't impose technical restrictions on those remote systems. Take a look at the out-of-the-box broadcasters currently available. You'll spot standard interfaces like the Customer Engagement Cloud Service and the XBRi broadcaster. This actually breaks down exactly who owns the interfaces. So, for instance, the Customer Engagement Cloud Service project team owns theirs, and it lists their very specific server authentication requirements, like whether they need proprietary custom authentication or OAuth. Section 2. 3 PosLog data formats, the languages of the dispatcher. When we compare how we can format this data, we're really looking at a classic trade-off. On one hand, we have the object format, commonly used by SOAP web services. This one is rigidly defined by XSDs, making it super easy for developers to just grab and manipulate data natively as objects. The catch? If a retailer adds custom data to the PosLog, you've got to modify those XSDs and recompile the code. On the other hand, we have the raw XML string format. Highly flexible. If you add new data to the PosLog, you don't have to touch the broadcaster code at all. But the remote server is forced to do the heavy lifting of parsing that raw XML string. And then there's the third style, the subset format. Think of this as a smart filter. If an external system doesn't need the whole massive PosLog package, the subset format lets the broadcaster pick and choose. Based on programmed logic, it can just send the exact pieces of information requested, like maybe just the transaction ID and the total amount, and completely ignore the rest. Section 3. The broadcaster database table inside the sorting facility. Okay, let's look at the engine powering this queue, the schema for the Tron PosLog work item table. What's really crucial here is how it uses the combination of the organization ID and the service ID fields. Since Xstore Office often serves multiple organizations, this combination rigidly separates and organizes the data. It ensures a strict, secure boundary across different organizations' data, exactly as you'd expect in enterprise-grade software. The actual journey of a record through this table is pretty straightforward. First, a PosLog is replicated into Xstore Office. Second, for every broadcaster you have configured, a new record gets added to the queue, tagged by its unique service ID. So 2 broadcasters equals 2 separate records in the queue. Finally, the work status is immediately initialized as new. The system is always on the hunt for the oldest new record to start processing. Section 4. Processing and error handling. Handling the return to sender packages. So the system is actively trying to deliver these new records. But what happens if a delivery fails? Well, a success scenario is easy. The broadcaster just marks the work status as complete and moves on to the next one. But the failure scenario is where the system actually gets pretty smart. It assesses the error. If it's a communication failure, like the server just couldn't be reached, it will keep trying until the connection is restored. But if it's an application-level error, the system logs the details and stops trying. It knows when to give up. This quote really hits the nail on the head. Let's say the broadcaster sends data, and the third-party system receives it but kicks it back because of a business rule, maybe an illegal tender type. At that point, the broadcaster's mission is technically accomplished. It delivered the package. The remote system just didn't like what was inside. So it absolutely will not endlessly retry sending data that's just going to get rejected again. Section 5. Maintaining system health, keeping the dispatch room clean. 3. That is the magic number here. With thousands of transactions flowing through every single day, you have to prevent the queue from overflowing. By default, records marked as complete are held in the queue for just 3 days before they're considered old news and get completely purged from the system. To actually make that happen, you'll rely on vendor-specific SQL scripts. These handle both technical and business tasks. On the technical side, they maintain peak database performance by recreating indexes and defragmenting the table. And on the business logic side, they execute the deletion commands to clear out those older, successfully processed records so your database doesn't bloat. Section 6. Customizing for your needs. Building your own broadcasters. Now for the fun part for the developers out there. When you're building a custom broadcaster, you'll generally subclass one of 2 main classes depending on your destination format. If your remote system wants raw XML, you'll use the PosLog string broadcaster. It hands you the XML string directly, so you can skip parsing entirely and just focus on writing the communication and error handling code. Alternatively, if you're dealing with Java objects or a subset format, you'll want the PosLog object broadcaster. It treats the data as simple Java objects, which is super convenient if you just need to extract a few specific pieces of info or if you're using something like dozer mapping. So we've walked through how the Xstore Office broadcaster system queues data, translates formats, handles errors intelligently, and how you can seamlessly extend the whole framework. Knowing just how incredibly flexible and powerful this technology-agnostic architecture really is, the only question left to ask yourself is, where will your custom broadcaster send your data next? Thanks for joining me on this explainer, and I'll see you next time.